So my name's Will, and I'm going to be talking about full stack development with the Grand Stack. So I work at Neo4j. I work on a sort of an integrations engineering team. So I spend most of my time building integrations with Neo4j. So I don't work on the core database itself. Instead, I work on building tools for making the database easier to use with your favorite web development framework or moving data back and forth between data services. While I'm talking, if you get bored, you can go to this link, bit.ly/graphhacker, and there's an Apollo Launchpad, which is like a demo GraphQL server. And if you follow some steps there to get it working with Neo4j, we will send you this t-shirt. We don't have any here, but if you just tweet about it, we'll get you the shirt. So something to do if you get bored while I'm talking. So the next few minutes here, I'm going to talk about Grand Stack, what it is, but then more importantly, why, what are these technologies, what benefits do we get when we use them together, and then since we're mostly developers here, we're going to focus quite a bit on the how. How do I use these technologies together? So first of all, what is the Grand Stack? Well, the Grand Stack is this idea of a combination of technologies that we can use for full stack development that when we use them together, we can leverage lots of important benefits for performance, developer productivity. We can also build really interesting integrations to make these technologies easier to use together, and we can leverage sort of symbiotic relationships between them. So first of all, GraphQL is a component of the Grand Stack. How many people are using GraphQL today or have used GraphQL? Okay, a few folks. So GraphQL is this sort of new paradigm for building APIs. It's an alternative to REST. It's not really a query language as you would think of a query language like SQL for querying databases. Instead, you can think of it as a query language for APIs. React, of course, our favorite library for building user interfaces. I don't need to say much about React since we're at the React meetup. Apollo is not just one tool, but rather it's a series of tools for working with GraphQL. So we see Apollo tools both on the client side, things like Apollo React, which is Apollo client integration for React, and then also tools on the server side for helping us build GraphQL servers, for performance monitoring, things like this. So Apollo is really a series of tools. We'll see a couple of examples where we leverage Apollo client and specifically the React integration, and then also some Apollo tooling that makes it easy to build GraphQL servers just using a schema. And then the final component of the Grand Stack is the Neo4j database. How many people are familiar with Neo4j or have used Neo4j? Okay, a few folks. So Neo4j is a native graph database. That means we use a property graph model, which we'll take a look at. We also use a query language called Cypher, which you can think of as SQL, but for graphs. And then, of course, we can use client drivers in lots of different languages. In this case, we're going to use the JavaScript driver for Neo4j. Okay, so those are the individual components. Like that's fine, but what are the real benefits that we get when we use these together? What is Grand Stack really all about? So I want to go through sort of an example of building a very simple web app for movie recommendations. And the code is out here if you want to look at this. It's on Code Sandbox. But the basic idea is we want the user to be able to search for some movie. Then we show that user some movie details, the plot, the rating, that kind of thing. And then we also generate some recommendations. So users who watched this movie also rated this movie highly, that kind of thing. And those kind of queries are really, really easy to express in a graph database like Neo4j. So we'll see how to do that. So these are how the pieces fit together in the Grand Stack. We have React on the front end. We have the Apollo client integration for React. User types in, River runs through it. We then use Apollo client to send that GraphQL query to our GraphQL server. Inside the GraphQL server, we have the logic for querying out to Neo4j. The data comes back, goes back through Apollo client. Basically, Apollo client allows us to bind components props to a GraphQL query, which is pretty cool, and then our front-end updates. That's roughly how the pieces fit together. So I want to start talking about the data layer piece of this, which is Neo4j. And so I think the easiest way to explain something is in the form of a tweet. So here's Neo4j in 140 characters. Neo4j is open source software that stores and queries data as nodes and relationships using the Cypher query language with index-free adjacency. OK. So let's unpack that a little bit. So first of all, Neo4j is open source. It's available on GitHub, also available through Docker. There are AWS integrations. We can clone it from GitHub, build it from source if we want to. Neo4j is primarily a database, so focused on accepting transactions, durably committing your data, but then also allows you to query this data as nodes and relationships. So this is the property graph model that we talked about. In the property graph model, nodes are the entities or the objects, and relationships connect them. We can store arbitrary key value pair properties on nodes and relationships. So this is the data model actually from the Panama Papers data set, which has recently been updated to the Paradise Papers data set. So if you're familiar with Panama Papers or Paradise Papers, these are leaked data sets that data journalists used to find importance people and their connections to offshore legal entities. They use Neo4j to do this, and this is the data model that they used. So we can see offshore legal entities, officers that are connected to them, intermediate law firms that set those up, and so on. So moving right along in our tweet here, so software that stores and queries data as nodes and relationships using the Cypher query language. So this is an example of Cypher. Cypher is very much about pattern matching. So on this first line, we're actually expressing a graph pattern. So we're saying find address nodes that have a registered address relationship to officer nodes. And then from those officer nodes, find any legal entities that they're connected to. Then we're filtering for addresses that contain New York. So this query essentially says, find anyone with an address in New York that has a connection to an offshore legal entity, and then show me what that looks like. So if we ran this query in Neo4j browser, we would see a graph visualization like this that we can then explore. We can see these sort of clusters where we may have tightly connected pieces of data. But we also might want to run an aggregation. Right? The result to our question that we ask a graph database is not always graph data. Sometimes it's tabular data. So if we modify our query slightly, we can say, OK, for all of these people with addresses in New York that have offshore legal entities, let's group by jurisdiction and get a count. So what are the most common offshore jurisdictions for people to use that have addresses in New York? Well, British Virgin Islands and the Bahamas, but British Virgin Islands is the most popular. Cool, so that's Cypher. Cypher is part of the OpenCypher project. It's an open source query language. There are other databases and other projects that use Cypher. There's a Cypher integration for Spark, so you can express Spark jobs in Cypher as well. OK, and the final piece of our tweet here is with index-free adjacency. So we query data using Cypher with index-free adjacency. And this is really just a fancy way of saying that traversing the graph is really fast. What this really means is that when we traverse from one node to any other, we're not doing an index lookup. We're essentially just chasing pointers, which computers are very good at. So what that means is that our queries for, on a data set the size of Panama Papers, which is a few million nodes, that same query can scale to a much, much larger data set without a performance impact because it's a constant time operation. So this is a really important performance characteristic of graph databases. Okay, so that's Neo4j in 140 characters. If you want to try out Neo4j, the Neo4j sandbox is the best way to do that. You can basically just spin up a Neo4j database that we host for you on AWS that has different data sets you can choose from and guided queries to walk through different use cases. So, okay, so we have some data in Neo4j, and we want to build an application on top of this. So it makes sense to use GraphQL for our API. We'll talk about why that makes sense. But first, let's talk a little bit about what GraphQL is. So we said that GraphQL is this alternative to REST, this new paradigm for building APIs. It starts with a schema definition. We define our types. We define our entry points for our GraphQL service. We said that it's really a query language for APIs. So that means that there's actually limited support for things like aggregations and filtering. There's also a really important community of tools around GraphQL, things like GraphiQL, which is this in-browser IDE for exploring GraphQL interfaces. We're going to take a look at that in a minute. But then also, because we have a strict schema, we can do cool things like mocking. So once we have our schema, we can use the types that we've defined to mock our API. That means we can build out the front end and the back end in parallel at the same time, which is really cool. So the schema is really important part of GraphQL. This defines what data is available. It acts as the specification for our API. And the client then sends a GraphQL query that specifies basically what piece of this schema it's interested in. That reduces the amount of data that's sent over the wire, and it means that the client can get all the data needed in a single request. So these were sort of the two main requirements of why GraphQL was created at Facebook initially. GraphQL also makes this observation that your application data is a graph, and that you should be able to traverse your application data. So here's a GraphQL example. We're looking up a business by ID, then we're specifying what fields we want to grab from this business object. And we can have nested objects here. There can be much more data available in the schema, but this is all that we're going to get back, just the data that we've requested. And note that our response matches the shape of our query. So this is really important. Oftentimes when people look at GraphQL, they wonder where is the graph piece in this, and it's really this observation that your application data is the graph. GraphQL allows you to traverse that, to extract out data from that graph. This implies that there's some mapping and translation layer then from how you're actually storing your data on the back end. So if you're using a relational database or a document database, there's some translation that has to occur to get graphs on the front end. So let's look at a really quick demo. So I spent some time today working with some Russian Twitter troll data. So I was going to show movies and recommendations, but I think this is a lot more fun. So if anyone's been following the news, basically Twitter released about 3,000 Twitter accounts that were tied to Russia. And of course, immediately suspended those, which means you can't get that data through the Twitter API anymore. So I spent some time scraping Internet Archive to try to grab some of these tweets, stick them into Neo4j, and then built a really simple GraphQL API on top of that, which is fun. So how can we query this with GraphQL? Well, this is GraphiQL, by the way, which is this sort of IDE for exploring a GraphQL API. So we can look at the documentation and we can see our entry points. We have a hashtag entry points. We can search for hashtags. We can search for tweets by text. Hashtag returns a list of hashtags. We have tweets on our hashtag, so we can see all of the types that are available to us. So in our query, let's search for the hashtag crime. We'll take the first 10 matches, and then here we'll grab the tag, and then all of the tweets in the data set that have this hashtag, we'll only look at the first 5, and we'll just grab the text. So the text of tweets in this Russian Twitter troll data set with the hashtag crime. And so it turns out that there were actually some accounts that were trying to make crime in Ohio seem like it was much more significant than it was during some sort of election. So these are the kind of fake news things that are being pushed to influence elections. And then on each tweet, there's more data here. We can also grab all of the hashtags from each tweet. We also have links, so any URLs that are embedded in the tweet as well, if they exist. And none of these have links, and they all only just have one hashtag. Cool, so that's just an example of querying GraphQL using GraphiQL. And that example was hitting Neo4j. So let's talk about how we build a GraphQL service on top of Neo4j, or really on top of any database for that matter. Well, the first thing we do is define a schema. And then once we define our schema, so once we define what types are available, then we need to implement what are called resolver functions. So for each type, for each field, we need to define how we're going to fetch data from the data layer, in this case Neo4j. This is not what our Russian Twitter troll schema looks like. It looks like this. So basically, we have type tweet, user, hashtag, link, and we can reference different types on fields. So for example, a tweet has a hashtags field that is an array of hashtag objects. So pretty simple. Every field has a type. Once we define our schema, and we define our schema using the schema definition language, which is this language agnostic way of defining a schema, which means that it's really useful for other tooling as well. So we look at a modified version of that diagram that we saw before. The only difference here is now we're saying that in our GraphQL server, there's something called a resolver function that has some logic for fetching data from our data layer. Here's what a resolver function can look like. So in this case, we're looking up movies by title. And this is an entry point for our GraphQL service, so it's on the query type. And we have a simple Cypher query in there that says, OK, take some substring and search for movies that have this title, and then return all those records as objects. And the way resolvers work is the entry point resolver is called, and then we see what fields we were able to resolve. Anything that was requested that we weren't able to resolve, then the resolver function for those fields gets called as well. So here we have genres, we have a recommendation query as well. So if the client has requested those fields, we'll call those resolver functions as well. So what you can see here is that we actually end up with several queries. We could even have as many as one query per field that we end up sending to the database. So typically we have to do some sort of batching to batch all these together for something relatively performant. So that led us to look at what sort of GraphQL integrations we could build with Neo4j to take advantage of sort of leveraging developer productivity. We actually wanted to see if we could be able to translate GraphQL to Cypher. If we have the schema, if we've defined the types, we should be able to do that. Would this give us some sort of improved performance? And then also, we said that GraphQL itself is fairly limited in sort of things like aggregations and projections. Can we expose Cypher through GraphQL? So we've built a couple of different versions of this integration. We have one for Java, one for JavaScript, which I wrote, that basically takes the schema, and translates arbitrary GraphQL requests to Cypher and handles the database call for us. And this one, the JavaScript one, is designed to work with any of the JavaScript server implementations, like Apollo Server, GraphQL.js. So how do we do this? Well, we use the schema. So we take your schema, and that then allows us to apply some rules to drive the graph database model. So that's the first step, is defining your GraphQL schema, and we infer the database model from that schema. And we then can translate arbitrary GraphQL queries to Cypher. And what that means is that's a single Cypher query. So before we saw we ended up with different queries for our different resolvers, but in this case we're generating just a single Cypher query. That means one round trip to the database. So we get improved performance from just having one round trip, one query to the database. We don't have to worry about batching. But then we can also expose Cypher in GraphQL. So GraphQL has this concept of a directive, which is essentially an annotation on a field. So we've added a Cypher directive that allows us to annotate any field with a Cypher query. So that field essentially becomes a computed field in our GraphQL schema. And when we do that translation from GraphQL to Cypher, that annotated Cypher query becomes a subquery in the single Cypher query that we generate. So it's still just one query that we're able to generate, which is really cool because it allows us to do interesting things with Cypher that we wouldn't otherwise be able to do with GraphQL. And the other really cool thing is that means that implementing our resolver is just calling out to this Neo4j GraphQL integration. So for that Twitter troll GraphQL server, this is all I had to write. All I had to do is write my schema, and then in my resolver, just pass through the arguments that my resolver function is called. The Cypher is generated automatically. The database call is handled for me. So that's really cool. That allows us to build GraphQL APIs with Neo4j really quickly. Cool. So I'm about out of time here. So I can easily skip the React section. We all know about React. We talked about Apollo being both a client-side integration for React, and then also tools on the data set, on the server side as well. I mentioned Neo4j Sandbox as a good resource. There's also a site, grandstack.io, that has some information, some tutorials. There's a starter for GrandStack for spinning that up as well. Cool, so we're about out of time. I don't know if we have any time for questions or not.
Super quick one. Would you consider that GraphQL Cypher integration production ready, or is it new enough that it's not quite stable to use in production apps?
Yeah, that's a good question. I guess regardless of how I consider the state of our integrations, we have people using it in production. So there's two versions. There's the Java one, which is basically a Neo4j plugin, so code that ships to the database, and Neo4j then becomes your GraphQL server. That one is a bit further along than the JavaScript version. The JavaScript one is not quite feature complete yet, but it's going to be. That's, it's largely feedback driven at this point in terms of what features we're adding. So I would say no, it's not quite production ready yet. But I guess that's depending on sort of your risk tolerance, because like I said, we do have people, actually big companies using that integration in production. So cool. Thank you.
Thanks so much.